Solving Trigonometric Equations by Justin D'Souza. The learning objectives of this lesson are to solve trigonometric equations and to find extraneous solutions from trigonometric equations. The keyword is trigonometric equations. Now, if you recall, in the previous lessons, we had solved a type of trigonometric equation itself, but that was a special type. It was called an identity. Now we are dealing with proper trigonometric equations. We are directly solving it and finding the answers. We'll look into them. But before that, let us recall some formulas which we require over here. These are the double angle identities. If at all we get any double angle, say you have 2 theta anywhere, please dissolve them to single angle. In the sense, it should be only theta. So you must use any one of these formulas and solve. We also know Pythagorean theorem, that is sine square theta plus cos square theta equals 1. That is also used plenty of times. Now, before we start solving, we have to have the knowledge of 16-point unit circle. You can see this is the unit circle. The first value over here is cos and the second value is sine. Now this keeps on going at different angles, say 30, 45, 60, 90 and so on. It is a must to know exactly what are the values for different angles. Now I'm sure most of you might find it very hard how to get those values. I will show you some tricks how to memorize them, because these were the methods which we used to use when I was in school. Now there is one more method, the calculator method, because you're using the scientific calculator. You can get them from the scientific calculator as well. So I'll show you both all the methods. Now this is the unit circle. Now these are the basic values you must require. It always starts from 0, 30, 45, 60, 90. There's a jump of 0 to 30 and then 15, 15, 30. Same thing over here, 90 to 120, it's 30 degrees, 15, 15, 30. And always remember the conversion of degrees to radians. It can be either asked in degrees or in radians. You need to know both the values. So what I generally prefer is, if I get the values in radians, I convert it to degrees. I mean, see, whenever it's 2 pi by 3, 3 pi by 4, I get it, it's 3/4 pi, okay, it'll be somewhere over here. But the degrees is more comfortable, because 135 degrees, yes, I can easily tell it's in the second quadrant. So this is something I personally do. I just convert it quickly to degrees. From radians, I convert to degrees and just use the degrees all the time. So this is one thing you also can do, and look into the option. If all are radians, it's fine. Do it exactly correct using the degrees, and then at the end convert it back to radians. We will see how to solve them. But now I will tell you the shortcut methods to remember this unit circle. The first method would be, by hearting those values in your mind. Second one would be the calculator method. First, let's look over here. The first row over here is about the degrees, 0, 30, 45, 60, 90. And these are the trigonometric functions, sine, cos, tan. Now, what you can remember is, you can do start sine 0. It's an easy value to remember. It's just 0. For all the other values, you can just start writing 1 by 2, 2 by 2, 3 by 2, 4 by 2. This is just I'm writing. These are not the exact values. Like even this can be like 0 by 2. It's fine. You can write it like this. And take all these square roots over here. Square roots of all these. So these are the answers. So what is root 0 by 0? It'll be 0 by 2. It's 0. This is 0 basically. What is root 1 by 2? It'll be half, because root 1 is 1. This is 2 root 2 as it is, root 3 by 2. Now what is square root of 4? It'll be 2 by 2, that is 1. So the final answers would be, you can see over here, 0 root, okay, you can just write it as 1 by 2. I've written it over there. And this is 1. So you don't usually see it as a root 1 by 2. It's 1 by 2 only, okay? Now what about the next one? Just write them other way. The 1 will be over here. The root 3 by 2 will be the second value. See, it's just changed. So whatever was first becomes last for cos, and the last becomes first. See, 2 is jumped over here. This one over here. This is same. This one over here. And last one, the first one. What is tan then? Tan is basically sine by cos theta. Now just divide. What is sine 0 divided by 1? It's 0. Now you can start dividing. It will be root 1 by root 3. So it will be 1 by root 3. You're just dividing them. Okay. Now this 2 root 2 by 2 root 2, it's 1 itself. Now what is this? Root 3 divided by root 1. Because this 2 and 2 cancels off anyways. It'll be 1 divided by 1. So just write root 3. And what about 1 divided by 0? It's infinity. So you'll have an asymptote over there. So this is how we can remember this. Now you can see even the other values are easy to remember from 0 to 360 degrees. Now you did the 0, 1 half, root 2 by 2, root 3 by 2, 1 for sine, right? Then when you're changing from 90 to 180, what's going to happen? This will continue. It's 1 over here. Root 4 by 2 is 1. Now you reduce the numbers. Root 3 by 2, this next. Same thing over here. Same thing. That's how we do it. Over here also we change. 0 is first, then half. Now this is root 1 by 2 is half. Okay. Root 2 by 2 and so on. But why is it negative here? It's from the cast diagram. If you recall the cast diagram, CAST. From 0 to 90, all are positive. No matter what, they are all positive. What about 90 to 180? It's only sine that's positive. So you can see sine is all positive, whereas cosine is negative. And what about this? Over here only tan. Sine and cos is negative. See, all are negative, both are negative. And lastly, sine is negative, cos is positive. This is how we can remember. Now, if you're finding this hard, no worries. Since you're using scientific calculators, I will show you the scientific calculator method. In the calculator, you need to first press on mode and we have to select the option table. Now, once you select the table, you will be asked for an equation. So f of x, you need to choose sine x. Let's do sine x first. Sine alpha x. Now, when you press equal to g of x, most of the calculators won't have this option. If you're there, you can put the second value as well, or you can do it separately. So you need to first write down the first values and then go back. But now in this case, let me do it separately itself because many of them won't have this option. And now where do you start at? I need to start, the unit circle is 0 to 360 degrees, right? So let me start at 0. Let me end it at 360 degrees. Now here the step. Now if I take 15 degrees as step, I'll get the values from 0, 15, 45, 60, 75, 90, 105, and it keeps on going at a step or an interval of 15 degrees. But sadly, if you press 15 degrees, it's too much to compute and it doesn't allow you. It says insufficient memory. So what you can do is, after putting the equation, only one equation, you start at 0, end at 360, put 30 degrees. 30 degrees would mean 30, 60, 90, 120, 150. So many of the values are obtained. So if your answer is in one of these, say for example 0, 30, over here you can see it's 1 by 2 or half. Now the problem is it gives you in decimal points. Now 60 degrees is root 3 by 2. If you solve root 3 by 2, you're going to get 0.866. So this is one way to understand, then 1 and so on. All the values until 360 are available. If you wanted cos, you can just do the same thing, mode 7 instead of sine, you could have put cos. But now, I will show you how you can get it if you get the values of 45 and so on. Now you can choose any sine or cos. Now this time I'm going to go with cos theta, that's x. Let's press equal to, this is now the only one equation. Let me start at 0. Now don't end at 360. If you end it at 360, you're not able to get 15, 45, all these values. So what I'll do is I'll half it up. I'll make it to 180 degrees and put the step of 15. Now this time you're going to get all the values from 0 in terms of intervals of 15 till 180. Now if you want from 180 to 360, all you need to do is again over here, same equation, sine alpha x. And over here there is no equation. Start at this time at 180 degrees and end it at 360. And now step is 15, you will get the remaining values. So this is how you can get all the values. Now if you know the unit circle, you will already have it. There are other ways also directly to find using the calculator, but the thing is, you won't get all the correct answers. Now we will look into problems, you'll understand much better. See, we have this problem. I have the unit circle over here, just for reference. Now we have sine times cos theta minus half cos theta equals 0. And this is another important thing. It's from 0 to 180. So whatever the answers we get is only within this quadrant, first and second quadrant, only these above values, not nothing else. So how would you solve this up? You need to solve it. You need to try and completely solve it, try to dissolve all the trigonometric equations. But now you can see sine and cos is multiplied, and over here there is cos. There is nothing much other than removing this common out. So what I do is I'll remove this cos theta outside. It will be cos theta in is removed, this and this, it's gone out. So cos is over here. What is remaining in the first part? Only sine, because cos is gone. It will be sine theta minus, over here this cos is gone, so you're remaining with half equals 0. Now look here, it's two different trigonometric functions. So even if you take this to the other side, you can't solve it up. You can't simplify anything further. So what we do in such cases, we just equate both of these to 0, because this means this multiplied by this is equal to 0. This or this is equal to 0. So what we write is cos theta is equal to 0. Sine theta minus half is also equal to 0. Now solve the sine theta. Sine theta will be positive half. So these are the two cases. Cos theta is 0 and sine theta is half. Is this over? No, we need to find theta, right? Let me just show in calculator. Let me take the calculator out. Here we have cos theta is equal to 0, right? How do we find this? In calculator, you need to take cos inverse on both the sides. You can't take divide by cos. You can take arc cosine, or that is cos inverse of cos theta equals cos inverse of 0. What happens is cos inverse and cos, this cancels off. You're remaining with theta is equal to cos inverse of 0. Now theta will be, if you just press shift cos, you will get cos inverse 0. This is the method. It's 90, because it's in the degree mode. I'm getting 90 degrees. So theta is equal to 90 degrees. That's fine. We got one answer. Now what about this side? Now I will tell you why we need this. You might be thinking, okay, we can just use the calculator. Why do we need it? But in a minute, I'll let you know. Sine inverse of sine theta. Both the sides we are taking sine inverse and sine inverse half. Only for this problem, I'm just writing sine inverse on both the sides. Otherwise, it's understood. Theta will be equal to directly sine inverse of half. This is bracket half. This is sine inverse. Now what else? What is theta? Now let me do sine inverse of 0.5 or half. It's the same thing. It's 30 degrees. Okay. Let me write 30. Is this over? Now let's refer the unit circle here. First one, values say over here, the x and y, right? This is basically x, y. X is cos theta, y is sine theta. So all the second values are sine theta. Here we got theta of 90 degrees when we did cos inverse 0. Now if you look at this condition, the first about this condition, cos theta is 0. When is cos theta 0? The first value you can see over here, up over here, cos theta is 0 when it is 90 degrees. Same way, theta equals 30 degrees. Sine theta is half. When is sine theta half? When it is 30 degrees. So that is how we find it. Now we found one answer, yes. You can see sine theta is half. But there are two answers. If you look, all the possible solutions from 0 to 180 degrees. Now 180 means, let's see, any other values over here. Can you see this half again? So there are two possible solutions. Even 150 degree will give you the same answer. So it's just not one answer here. You need to write theta is 30 degree, yes, but there is also theta equals 150 degrees. So these are, all the three are the solutions from 0 to 180. So it's just not the, two solutions, it's three solutions over here. Here it's just one. Why is it? because cos again becomes 0 at 270 degrees, but 270 is out of this domain. So we don't consider, we consider only from 0 to 180 because I've clearly mentioned it. This is the answers. I'll just check the answers over here. Yeah, that's it. Nothing else. 30 or 150. This is how we solve it. Now, these are the three solutions. Let's look into one more problem. Oh, no, sorry, this is the same thing. It is just a check. If you have graphing calculator, you can check by graphing it and checking the values. Now, one more thing is by the table method which we saw, we will get these values at these particular points. At sine theta half, you will have 30 or 150, and cos theta is 0 at 90 degrees. Now we will see one more problem over here. We have sine 2 theta equals cos theta. What do we do over here? First of all, there is 2 theta. This is double angle identity. Solve this up. How do you solve it? It is sine 2 sine theta into cos theta. This is the rule for sine 2 theta, double angle identity. We have done it in the previous lessons. And over here equals cos theta. You need to bring it inside over here. It will be 2 sine theta cos theta minus cos theta equals 0 when you bring it inside. Now what you can do is remove the cos term common out. Cos theta is common, so you will have 2 sine theta minus 1, that is equal to 0. Now you have two solutions over here. Cos theta equals 0 and 2 sine minus 1, 2 sine theta minus 1 is equal to 0. So we know what is cos theta equals 0 at. It is at 90, and since they have given in pi, we can write in pi, but you can write it later. Here it's until 2 pi, so it is 90. Yes, one answer is 90 degrees. When is cos theta 0 at? At 90 degrees and at 270 degrees and 270 degrees. Now here we have sine equals positive half. Sine theta equals positive half. When is it half? So it is at 30 degrees and 150 degrees. Now, if you want to convert them to radians, you can just write, the theta is 90 is always pi by 2 because 180 is pi, this half of it, and 270 is 1.5 pi. But we write it as 3 by 2 pi generally, 3 pi by 2, or 1.5 is the same thing. Because see over here, this much is 1 pi, this is 1.5 pi, this is 2 pi. Now 30 is over here pi by 6 and 5 pi by 6 is 150 degrees. If you're thinking how did I convert it, I'll show in calculator the conversion as well. All you need to do is 150 degrees, right? The shortcut method would be 150 divided by 180. That's it. Always divide by 180. What is it? 5 by 6? Just add a pi. But in reality it is multiplied. This will be 150 will be multiplied by pi, sorry, it is shift and this pi symbol, and the whole answer will be divided by 180. That is the thing. It's 5 pi by 6. Now the actual way, now we have 270. 270 is basically multiplied by pi divided by 180. And this is the answer. But if you directly do 270 by 180 without multiplying, you'll get 3 by 2 and just add a pi later on. That's also fine. So these are the solutions. You can see over here it's pi by 6, pi by 2, 5 pi by 6 and 3 pi by 2. They write in ascending order. 30 degrees is the least, then 90, then 150 and 270. So those are the solutions. Now, trigonometric equation solutions. Now, what if they give you a domain of all real numbers in the sense from minus infinity to infinity? The thing is, all these trigonometry circles, as we have seen, it's repeating. This is a circle. That means it keeps on repeating, and all these trigonometric functions are basically like this wave. They continue the same thing. The values over here will be 1 all the time. Over here it will be minus 1. They are the same thing. Repeats after every certain interval. So what happens is after 2 pi, again will come over here. It'll be just, see now, this is 330, right? So 360 plus 30 is 390. So we will, at 390 degrees, the same values. Then Add 15 to it, it'll be the same thing. From 390, it'll be 405, and so on. So that's why what we can do is, instead of writing all the answers, we can write it as a multiple of an integer. In the sense, we will see now in a problem how we write it is. See, they are just saying multiples of the period of the function. Now we have this particular problem where cos theta plus 1 equals 0. Now this is very simple. You can just do cos theta equals minus 1. Here they have not mentioned any, say for example, they have not mentioned any restrictions of the domain. Now when is cos theta minus 1? If you recall, it's only minus 1 at 180 degree. See over here, this is the unit circle. At 180 degree, cos theta is minus 1. There is no other value of negative 1. Sine is negative 1 at 270. You should always remember this. So we know the answer is pi, right? That is 180 degrees. But here they did not mention any 0 to 90. It's not mentioned. So that means one answer is at pi or 180 degrees. Also, it is true at 3 pi. Let's look over here. Where is minus 1? At pi, yes. But this curve, it keeps on going, and again at 3 pi it will reach the same point. If you go back, minus pi is the same thing. You can just do plus or minus 2 pi and you will find minus 1. So cos theta is minus 1 at various points. That is all the different integer multiples of pi. So how do we write this is basically, here, see the possible answers are pi, 3 pi, 5 pi, minus 3 pi, minus pi. You can't just keep on writing it. So what we do is basically, you write pi because that's the solution, and then plus, it's every 2 pi it keeps on repeating, right? K is an integer multiple. K can be 1, 2, 3, 4, minus 1, 2, 3, 4, and so on. So if you say multiply k of 5, it'll be pi plus 2 pi times 5. You will have pi plus 10 pi, that's 11 pi. Yes, at 11 pi again you will have negative 1. So this is the solution. You can have all possible solutions. So you just write pi plus 2k pi. In this problem here, we have cos 2 theta plus 1 equals 0. What do we have to do is, first, cos 2 theta, write down the formula for cos double angle identity. It is either cos square theta minus sine square theta, or we have 2 cos square theta minus 1, and the last one is 1 minus 2 sine square theta. Now here, which helps us? Look, the first one, no, it'll just be more complicated. The second one can be used, but then you have 2 sine square over here, cos square, it's not easy to simplify. But this one here is the most ideal. Why? Because the 1 and minus 1 also cancels off. Now you can look over here, there is cos theta, then cos square. You can easily remove 1 theta out, isn't it? So in such cases, always go with 2 cos theta. Now let's apply this. 2 cos square theta minus 1 cos theta plus 1 equals 0. Minus 1 plus 1 cancels off. You will have 2 cos square theta plus cos theta equals 0. Now remove this cos theta outside. It will be cos theta 2 cos theta plus 1 equals 0. Now this is done. We have simplified it. You can write cos theta equals 0, and you can write 2 cos theta plus 1 equals 0. This will be cos theta equals negative half. Now when exactly is cos theta 0? Cos theta is 0 when it's 90 degrees. So one answer is 90. And when is it again 0? At 270 degrees, isn't it? This only for 0, it keeps on repeating more often than anywhere else. So now why? Because now the cos graph is something like this. Okay, it keeps on going. Now if you see this 0 point and 0 point, whereas let's take first 1 and 1 point. When does it repeat? 1 repeats only after 2 pi, its period. Now what about this point? This also repeats only after 2 pi, after its period. But look at 0. 0 keeps on repeating after pi. Again, after pi, it's 0, 0, 0. Cos theta is 0 at every pi interval. That is one important thing which you must remember. And what about negative cos negative half? Cos negative half is 1 at over here, that is 2 pi by 3 or 120 degrees. And then you will have one more over here, that is 240 degrees. So these are the answers. But you do not need to write 270 because we know it's until infinity, right? So what we write is we write 90 degrees plus, we know at every 180 degree at pi interval, that is 180 degree, it keeps repeating. So we write 180k. Whereas all the other values, now there is what over here, cos theta is half at 120. This we write k into 2 pi, or it's 360 because it doesn't keep repeating. Now where is this negative half? Negative half is somewhere over here, right? This repeats only after 2 pi, that is 360 degrees. So we can write 360, and this one 240 is also after 360. So the answers are only three: 120, 240 and 90. These should be the final answers, not everything else. So this is it. Now I'll recall over here, because we got cos theta equals 0. When we have 0, it is a special to write over here. It's only 180 degree, not 360. It keeps on repeating. Cos theta will cut 0 every 90 degree. Same does the sin theta do. When is sin theta 0? It's at 0 and then again at 180. So again at every pi values, that means every 180 degree it touches 0. So that's why whenever you get cos theta equals 0 or sin theta equals 0, we can see the interval is k into 180. Whereas any other value, it will always be 360. So you can memorize it, 360 or 2 pi. For these only for 90 degree, it repeats at 180. That is because we should know the graph of sine and cos. Now, what about this problem over here? We have 2 sine theta equals minus 1. So this is very straightforward. There's nothing much. Sine theta equals negative half. Now, when is sine theta negative half? We know it cannot be in the first quadrant, second quadrant. It's down in the third quadrant. Now, if we know the unit circle, we can easily see over here, because over here all sine, the second values are positive. Positive. Even over here, they must be positive. Over here, we have negative half. So one value is 210, but that's not it. There is one more value, that is 330 degrees. So we can write two values. Now over here they have written in radian because they have asked in radian, but you can easily see after this you need to see, right, the unit circle. You can check 210, 330. And these values can be converted. Just divide by 180, you will get 7 by 6 pi. And remember, since it is not 0, see this is not 0, it will be 2 pi. Only when it is 0 over here, it will be k into pi. There won't be that 2, won't be there. Okay. So that is how we solve these. They're pretty straightforward now. Okay, we have a real world problem. When you ride a Ferris wheel that has a diameter of 40 meters and turns at a rate of 1.5 revolution per minute, the height above the ground in meters of your seat after t minutes can be modeled by the equation given over here. Height is equal to 21 minus 20 cos 3 pi t. After the ride begins, how long is it before your seat is 31 meters above the ground for the first time? So you need to find how long the Ferris wheel starts. Will your seat be 31 meters above the ground? So over here they have told a Ferris wheel is turning, everything is there, and this is the model. So it keeps on going. Now if you start at 0, how long will it take your seat to become 31 meters above the ground? Like how it starts over here, how long? So we need to write the original equation, which is this equation. Let's I think so it's there. Okay, let's just refer that equation, then we will solve. Now here it is very important to write this as it is and understand that instead of cos theta we have 3 pi t. There are different methods to solve. The method I will solve is considering this as theta. I will take theta equals 3 pi t. And now write this equation. Now what is this height? We need to solve for height. What is the time when the height is 31 meters above the ground? So this is the height. 31 equals 21 minus 20. Now I know t is in this, but I will write just cos theta. Okay. Now let me solve. 21 to the other side will become 10, right? 31 minus 21 is 10 equals minus 20 cos theta. So divide both the sides by minus 20, you will get 10 divided by minus 20, and over here also divided by minus 20. You're remaining with, I'll write it over here, minus half equals cos theta, or cos theta equals negative half. When is it negative half? When cos theta is negative half, it will be negative half when over here you can check at 120 degrees and over here again at 240 degrees. So these are the two possible values. Now, since over here we have pi, let me write in radians directly. 120 is 2 pi by 3. The answer is 2 pi by 3, and we have 4 pi by 3. These are the two possible answers. Here, what happens is, you know, the interval, the period of cos theta is 2 pi k. Don't forget to write that, plus 2 pi k. Okay, 2k pi. It's the same thing as long as you written it properly. Now this is the theta. Theta equals this, and this is the solution. But do you know what did I assume theta to be? I did not write it because here if you put this value, the period is not 2 pi, it changes. But we need to solve the change in the period as well. So always, whenever you have more than something over here in cos theta, always assume that to be theta and solve. This make it theta and start solving. Now I got two thetas, right? Now substitute the theta value back. 2 pi t is equal to 2 pi by 3 plus 2 pi k. Now why? Because if I divide both the sides by, see, I want only t time. I don't want this. So divide by 3 pi here. Here also divide entire thing by 3 pi. So what happens is this pi and pi cancels and it will be 2 divided by 9. Over here also divide by 3 pi. This cancels. So here t is equal to, this comes over here in the denominator of the original term. 2 divided 3 times 3 is 9, plus here we have 2 by thirds k. This is the new answer. This is the new period. Every 2 by 3 times pi, it will start repeating. Not at 2 pi, because over here it is not just theta, it is a different term. So period changes. Now what about this one? Here also substitute, instead of 3 pi, theta, 3 pi t. 4 pi by 3 plus over here we have 2 pi k. Now divide all the sides by 3 pi and you will be getting t is equal to 4 by 9 pi plus 2/3 k. Now look here, this is a real world problem. You're not going to take negative values, but you must see both are possible answers. Yes, every 2/3, this is repeating over here also, this is repeating 4 by 9, the 4 by 9 pi. But which is the actual answer? Just solve this and this in the calculator. You will come to know 2 by 9. Here they have told t in minutes. So let us use our calculators to solve this. Now here we have 2/9 minutes. Okay, now sorry, this one over here, it's 2/9 minutes. That's 0.222 minutes. How much is it in seconds? Multiplied by 60, you will get in seconds. That is 13.33 seconds. Now even do the same thing over here. So I will directly write it over here, 4 by 9, and the seconds is 26. Now, this is multiple of 2, yes. If this is 13.33, this is 26.66. Now, that means every 13 seconds, you can see it passes through this particular height, 31. But we are not considering the higher value. We have to consider low value. Why? Because imagine this is a Ferris wheel. Okay, the circle. Here you start. First time you will reach 31, meters in 13.33 seconds. So this is the correct answer. Again, it will, yes, go, but we want only, because here in the question they have told after how long after the Ferris wheel starts will your seat first be 31 meters, means first time only. So we do this. Now, why did I write all this? If it's in writing, this is important to show the period and everything. This is crucial to understand how we write each and everything. So that's why please make sure you understand this writing. But here we can directly get the answer. And I'll tell you a small shortcut over here. So what you can do is, if you are directly substituted this as cos instead of theta 3 pi t equals negative half, right? You could have taken cos inverse. It will be 3 pi t equals cos inverse of half, sorry, negative half, and then divide this entire thing by cos inverse of negative half divided by 3 pi. Now I'll put this entire in the calculator now, and we will see. Here it is cos inverse of negative half, that is 0.5. Now, very important thing, because I'm using pi, please change it to radian. Or if you want to avoid that, what you can do is you can use this pi in terms of 180 degrees, because now my mode is in degrees. I can't use pi as radians, because pi means it's always in radians, right? What is pi degrees? Pi means 180 degrees. So I'll write 3 into 180 degrees. Now here we directly get 2 by 9. But what if they asked second time here? Then there is no way you can use this method to solve. Then you have to recall the previous, just a while ago I did, right, the two solution. That is the method. Only in this case, because they asked the first value, first time, it will reach 2 by 9, that is in minutes. Then when you multiply into seconds, it will be 13.33 seconds. You're going to reach 31 meters. But again, it will reach, second time it will reach at a different stage, so that's why we had to write the period. Just refer back what I did over there for the period, that is important. And here, see, here they have done a little differently, because see, I had taken this entire thing as theta, right? Try to follow that method, because that will be easier. Over here they have not taken that theta. It will be a bit confusion if you're trying to solve it. Over here I've just written theta, then solved it, and then simplified it, but they have not written it like that. It's fine, both the answers are correct. You can see this 2 by 9. When you solve this, we get 2 by 9th of a minute, or 13.33 seconds. So that is the answer, not this one, because the first time is over here. And here the same thing again at 41 meters. So I will just do it over here again. Just let me just solve a little bit. Then you need to try to do it by yourselves. All you need to do is change it 41 to 21 minus 20 cos 3 pi t. Now please pause the video and try to solve this by yourself, just like what we did a while ago. I will do this because the methods are not there in the next slide. How it is done is, first take this 21 to the other side. It will be 41 minus 21, that is 21 equals 20 cos. Instead of 3 pi t, I'll write theta. Then take it to the other side. We divide both the sides by 20. I'm sorry, this will be 20. 41 minus 21 is 20. Now we will get 1. Pause. Over here it's minus. I forgot to write that. It'll be minus 1 is equal to minus 20 by 20 by minus 20 is minus 1 equals cos theta. Now when is theta equals minus 1? Theta will be equal to minus 1 over here when it is 180 degrees. So the answer is theta equals pi. I'll write in terms of radian because we have this pi over here. Now don't forget to write plus 2 pi k. Why? Because negative 1 comes only after 2 pi. This is how we write it. This is the period, because it keeps on repeating. But now in this case, since we are doing the first time only, first seat only, first time when it reaches that height of 41 meters. So what we do is we will substitute this 3 pi as, sorry, theta as 3 pi t equals pi plus 2 pi k. Now divide all the sides by what? 3 pi. You'll be having t is equal to, when you divide this pi by 3 pi, pi and pi cancels, plus 2 pi k by 3 pi. So this cancels. The answer is t is equal to 1/3 plus 2/3 k. Now, since we are doing the first seat, this will be 0. This will not be used. Only the first term will be used. T is equal to 1/3. This is minutes. Okay, 1/3 is 0.33. But if you multiply this by 60, it will be 20 seconds. This is 20 seconds. That's the answers. Okay, that's the answer. It's either 1/3 of a minute or 20 seconds. We can see the answer over here is, yeah, 20 seconds. It's not about, it's exactly 20 seconds because we get 1/3. But if you write 0.33, yeah, it will be, yeah, very close. Before we go to the next topic, a quick reminder, please do subscribe to my channel. If you're finding these videos helpful, please do like the videos and share it with your friends who might find it helpful. All those who have subscribed, all those who are liking and sharing the videos, thank you so much. This means a lot to me. Extraneous solutions exactly means sometimes you'll get two solutions, but one set will not be true if you put it back into the original equation. That is extraneous. You get all solutions, you need to test each one. Is it true or false? And then you can neglect some. But here in this trigonometry, sometimes if you get equation, say cos theta is equal to 4, the range of cos theta is just -1 to 1, because look at this graph of cos theta. It starts from 1, it goes down and comes up. It's only till from 1 to -1. There is no way the answer can be outside this. I'll prove that in the calculator. Let's take our calculators. You can type any value over here for cos and it will be within the range of -1 to 1, because you cannot have anything other than this range. But how can we check whether it's wrong? So now let me just do cos inverse of 2. It is how much? More than 1. It's an error. But if I do anything within 1 or less than 1 till -1, say minus 0.799, I'll get the answer. But if I do say is 1.01, I will get a math error. Can you see? Because the range is only from 1 to -1. There can't be other solution. Here we have an interesting question to solve this equation. We have over here square, no square, just a sine theta and a number, and equal to 0. How would you solve it? Now, if you're thinking, okay, I will take this 2 to the other side and then take common term, then it's wrong. See, for example, you're saying I will remove this 2 to the other side, will become positive 2. And over here, what's remaining? I'll take sine theta. What remains over here is 2 sine theta minus 3, right? Because sine theta is gone. And then if you start solving, equating to 0, this will be wrong because they are 2 multiplied equal to 0. This is not a product property. When you have two multiplications, it can be equal to 0. That is a zero product property. You can't directly tell this and this is equal to 2. Both are equal to 2. No, that doesn't make sense, This equal, let me just go back. You can't equate this is equal to 2 and this is equal to 2. Why? Because then 2 into 2 is equal to 4, which is not true. Whereas in case of 0, if this was 0, then yes, we can definitely say this must be equal to 0 or this is equal to 0. So there are many solutions. So that is how it is. Now here, for this case, what we need to do is we need to recall quadratic equations. Now assume sine theta equals x. And let me rearrange this. 2x square minus 3x minus 2 is equal to 0. Now you know this is a quadratic equation and you can solve it up. Let's take out our calculators and solve it. Now here let us substitute in mode 5 and 3, that is for quadratics. The first value is 2 minus 3 minus 2. The answers are x is equal to, let me write it over here, x is equal to 2 and what is the other answer? It will be x is equal to negative half. So let me write it out over here. X is equal to negative half. These are the two answers because it's power 2, maximum 2 answers. Now this is x. So let's substitute back x as sine. Sine theta equals 2 and over here sine theta equals negative half. This is it. It's only changing this. Now if you look over here in the above equation, there is no way you can simplify this. No way this 2 cancels or anything. So therefore we need to realize this is having square and no square. Such cases, use this, simplify and use it. Now we got the answers. Now if you recall the the unit circle, we can easily solve it. But before we solve this, look here. Can sine theta be equal to 2? If I take sine inverse of 2, what's gonna be? Shift sine inverse of 2 is math error. Why? Because this is out of the range. Now, if you look at the unit circle, okay, the unit circle is not. Let's just go back for the unit circle in the previous one over here. Look at the unit circle. Can you see any answer of 2? It is starting from 0 for sine, I'm talking about, right? At 0, 1, 0, minus 1. It is always within this. It will never go more than 1 or minus, it will never go more than 1 and less than minus 1. So this is wrong. But minus half, yes. We have 1 minus half at 210 and 1 more minus half at 330 degrees. So the answers over here will be these two. This is one is 210 or 7 pi by 6 and then 330 degrees or 11 pi by 6. That is how we get it. Okay, this is how we solve it. And here you can see left side, it is not inclusive within the range. So there's no solution for the first part. And you can check the answers. You can check it by putting it back into this equation. Now, if you found the two answers, right, that was 330 degrees and 220 degrees, I believe. So if you put it back in theta, you must get the right side equal to 0 if you solve it. You will get for both these answers. Now, this question is also an interesting one, just like the previous one. Here, it's not easy to solve because you have plus and here it's plus again. If you take this to the other side, it'll be sine minus cos theta. There is not much you can do because there is no identity saying sine theta minus cos theta. No, they can't do anything. Now, what can you do? Over here, there is one. The closest you can do is square both the sides. Now, there are other methods which will just be more complicated. This one is one of the easiest one, just squaring on both the sides. If you square on both the sides, left side will be sine squared theta. Here, you'll get 1 plus cos theta the whole square. Left side, there is no problem at all, but the right side, you need to use the a plus b the whole square identity. Here, a plus b the whole square, that is equal to what? A square plus 2 times ab plus b square. This identity needs to be used. There are sadly no other shortcut methods exactly over here. After this, we can do it easily. Let us do this. Square the first a. That is 1 square is 1 plus 2 times 1 into cos theta is 2 cos theta plus second term square cos square theta. That is equal to sine square theta. This much we have now just simplified the powers. Now what else can we do? Now then you can do, see the sine square theta is there. We know Pythagorean theorem, sine square theta plus cos square theta equals 1. So what if you take cos square to the other side? You will get sine square theta equals 1 minus cos square theta. Why we are doing this is so everything will be in cos theta. We can easily simplify this then. So I will change this 1 minus cos square theta. Now what we will do is, this is over here the same thing, 2 cos theta plus cos square theta. Now we will get everything to one side. Now I can bring the right side to the left side or left to the right. See, 1 to the other side becomes minus 1. When the same signs are there, this cancels off. You're only remaining with minus cos square theta, 2 cos theta, cos theta. So what I'll do is I'll get this to the other side. So it'll be 0 is equal to 2 cos theta plus cos square theta plus cos square theta. This is the thing. Now we can simplify. This is 2 cos theta plus 2 cos square theta. Now it looks much easier, isn't it? This is equal to 0. So now you can remove the terms common out. You can use quadratic also, make this 2x plus a 2x squared, but that is just too much. You can do an easier method, that is remove 2 cos theta from both the sides. You're remaining, this 2 cos theta has gone out, 1 plus here 2 is gone, cos theta is gone, only cos theta remains. This is equal to 0. So this both can be equated to 0. It will be 2 cos theta equals 0 or 1 plus cos theta equals 0. Now here cos theta will be equal to 0 when you divide both the sides by 2, and over here you will have cos theta equals minus 1. Now it's very not very easy. If you recall, 0 and 1 or minus 1 is easy to remember. Now 0 over here means it's 90 or 270 degrees. Plus every pi interval they repeat it. And over here minus 1. See, it starts with 1, then it goes 0, then it reaches minus 1, 0, and it continues. So it is over here 180 degrees. Okay. So answers are 90, 180, 270. Let's just check the answers over here. 90, 270 and 180, and those are the answers. You can see it's 180, 90, 270. That's how we solve it up. Let's practice few problems. Now looking at this problem, I can realize if I manipulate this one and get into cos, I can cancel over here, right? Now just now we did, what was it? Sine square theta equals 1 minus cos square theta, isn't it? So I will just use the same thing. Instead of sine square theta, I'll write 1 minus cos square theta plus 2 cos square theta equals 4. Now take this 1 to the other side, it will be 4 minus 1. But you can see here, this is like x plus 2x. Cos square and cos square, it's the same variable. 2 cos square theta minus cos square theta is 1 cos square theta. It is basically like minus x plus 2x, right? It will be minus plus x. That's it. I hope that's clear. And this one, I'll take it to the other side, is equal to 4 minus 1. So I'm getting cos square theta equals, how much is it? 3. Take root on both the sides. Cos theta will be equal to plus or minus root 3. Now root 3 is about 1.7. So is there any solution now? Cos theta cannot be, plus or minus 1.73 or something. It's wrong. There is no solution for this. Why? Because this is outside the range of cos theta. This is an easy one. There must be no solution. Yes, no solution is the answer. Now let's look into this one over here. Again, we have sine, cos. Okay, this one, right? When I look at sine minus and cos plus, take it to one side. It will be very, very easy. I will do cos square theta. Take this to the other side, plus sine square theta equals 4, and 3 to the other side becomes minus 3. Is that okay? Because plus becomes minus. Now, what is cos square theta plus sine square theta? It is 1, Pythagorean identity. This is 1. Now, here we are getting a number, and over here also, 4 minus 3 is 1. What is this basically? It's an identity. No matter what, the solutions are true. Whenever we have identity, it's like, a plus b the whole square equals a square plus 2ab plus b square. Now, if you assume certain values, a is equal to 2 and b is equal to 3, substitute a and b and square them left side, and over here it will be the same no matter what. You can change these values. A can be any integer n and b can be anything, any value, not an integer, all real numbers, 2, 4, 6. Substitute, it will always be true to both the sides. Here, when we solve, we are getting 1 and 1. Yes, this is an identity. It's true all the time. Okay, so you can put any theta value, you'll get the same thing, the same answers. Over here and over here will be the same answer. So you can try that by substituting any theta value left side, and then over here you will get the same answer. It's an identity basically. Therefore, all possibles, all infinitely solution, infinitely many solutions. Here we have another tricky sort of problem. We have secant square theta tan to the power 4 theta. So the first thing what you need to do is, when you see secant theta, convert this. This is a Pythagorean identity. We know secant square theta equals 1 plus tan square theta. Let's substitute this over here. Instead of secant square, you have 1 plus tan square theta minus tan to the power 4 theta equals minus 1. Now substitute, multiply this over here. 2 plus 2 tan square theta minus tan to the power 4 theta equals minus 1. Let's get everything to one side. I'll write the highest degree first. This is tan to the power 4 theta plus, sorry, it's minus tan to the power 4 theta plus tan square theta plus this 2 minus becomes plus, 2 plus 1 is 3 equals 0. Now here when you look, there is a jump of two powers, 2, 4. You can use quadratic formula. If you assume tan square theta equals x, what happens? Tan to the power 4 theta is equal to x squared then, right? Because square this whole thing, it'll be power 4 over here square. So minus x to the power 2 basically. Tan x to the power 2 is how much? X to the power 4 is x squared. Minus x squared plus 2x plus 3 is equal to 0. You can use your calculator and solve this now. We can go to mode 5 and 3 and now substitute. What is before x squared? Nothing, that is minus 1. Then we have 2 and lastly we have 3. The answer is 3. So let me just write x is equal to 3 and we have got x is equal to minus 1. Only two answers, 3 and minus 1. So another, and x is equal to minus 1. Now what is x? We initially assumed x to be tan square theta equals 3. This is the thing. Over here, again, tan square theta equals minus 1. Can a square be negative 1? How do you solve this? Basically, you have to take square root on both the sides. What happens here? Tan theta will be square root of plus or minus square root of negative 1, which is an imagined number. So this is does not exist. It's an extraneous. It's no solution. What about this one? Take square root on both the sides. It will be tan theta over here plus or minus root 3. So you have two solutions. Okay, now what you can do is, since it's root 3, for tan, we can generally use the calculator, okay? Instead of the unit circle, just do shift tan inverse of 1 will be root 3. Okay, this is the first. You need to put it up properly in the calculator. It's 60 degrees and then change it to minus root 3. It will be minus 60. So the answer over here is basically two answers. Theta will be 60 degrees and minus 60 degrees. So these will be the two answers. You can see when we solve, let's just check. In the right side, there is no solution. It's because the square root can never be negative. And over here, it is 60 and minus 60. Okay, there's one more thing to tell, which I forgot. The period of tan is only 180 degrees. It's not 360. So all the values, whatever you get for tan, will be repeated because the tan graphs are something like this. They keep on, sorry, it's like this. They keep on repeating after 180 degrees. Every time after 180, they repeat. So please remember, you have to write 180 degree K. That's it. Here we have the problem of sine theta cot theta minus cos square theta equals 0. Now let's try solving this. Over here, we know cot theta is there. What is cot theta exactly? It is cos by sine. Cos theta by sine theta. Now, here these both cancel off. And we have remaining with cos theta equals 0. Let's simplify this. Cos theta, you can remove it outside. And what happens? 1 remains minus. There are two cos thetas over here. Only one will remain equals 0. You can equate it to 0. Cos theta equals 0. 1 minus cos theta equals 0. Here it's done. But over here, what do we get? This is minus cos theta. Take cos theta to the other side. It will be plus cos theta equals positive 1. What are the answers? If you look at the unit circle, cos theta is 0 at 2 points. 90 degrees, 270 degrees. We have done this many times before. When is cos theta equals 1? Only at 0 degrees. Now, there is one important thing you must know. We had cot theta. Cot theta is undefined at 0. It's an asymptote. So if you tell theta is 0, does it make sense? Here it becomes undefined. You can't have any undefined points. So this is basically extraneous. We are not using this. This solution cannot be used. But 90 and 270 are, yes, absolutely right. No problem. But you don't need to write both because it's minus infinity to infinity. You just write 90 plus, we know this repeats every pi, right? After 90, again add pi 270, again 270 because sorry, that's a very bad line. Now over here, cos theta is 0 over here and 0 over here. Again, every time it will repeat at that time. So I will write at pi, that is every 180 degree K. So that is the answer. You can see over here 0 and 0. Whereas this is also true. At 1, it's at 0 degrees, but we can't use theta of 0 because it's undefined over there. So the answer is, now, because it is in degrees, you write pi in degrees, that is 180 degree into k. That's it. K is just an integer. Now the last problem of this lesson, let's solve this up quickly. Over here, cos theta divided by cot. So what I'll do is I'll substitute, cot is 1 by cot is tan, right? So instead of 1 by cot, I'll write multiply by tan theta plus 2 sine square theta equals 0. And now you can do cos theta into sine theta divided by cos theta plus 2 sine square theta equals 0. Now what is this? Sine theta plus 2 sine square theta equals 0. Now we can easily remove sine theta outside. Sine theta will be here 1 plus 2 sine theta equals 0. Now it's sine theta equals 0. So the answer over here will be 0. Theta is 0. And what about this one? 1 plus 2 sine theta equals 0. Okay, sine theta equals 0. So it will be, take this to the other side, it will be 1 is equal, let's take 1 to the other side. Okay, I'm just scratching it over there. 2 sine theta equals minus 1 and sine theta equals negative 1 by 2. Now, when is sine theta negative 1 by 2? If you look at the unit circle, we have two values that will be in the third and fourth quadrant. That was 200 and, it's 210 degrees and at 330 degrees. So sine theta is over there. Those two are the answers. That is, uh, it's written in pi, that is 7 pi by 6. See, negative of it 7 pi by 6 and 11 pi by 6. Now, why we do not consider this 0? Why? Because again, cot is undefined at 0, right? You can't have this. Because sine 0, yes, exists. But cot is basically cos by sine. Sine 0 is 0. It's undefined. This again gets undefined. So we are ignoring this part. Only these two are the answers. See, we got sine theta is equal to half, right? Half is 7 pi by 6 and 11 pi by 6. And always remember, other than these 2 points, all the points are repeating at 2 pi or 360 degrees. So we write 2 pi k or 2k pi, anything is fine. So this is the interval it repeats. So finally, we have reached the end of this lesson. I hope you have benefited from it. I hope you found the explanations helpful. These problems are tricky. Please do practice more problem. And a quick reminder, please do subscribe to my channel and please do like my videos and share it with your friends who might find these helpful. Thank you guys, and I will see you in the next video. Until then, happy learning.